Here, we imagine spacetime itself as not merely curved, like in Einstein's theory, but also endowed with torsion, a localized twist or contortion that forms swirling structures. Each node or lump you see corresponds to areas where k², that is, the density of contortion, is intense. Meanwhile, the filaments linking these lumps reflect how torsion can stretch across space, weaving a dynamic web. In conventional relativity, matter and gravity are treated as distinct, mass-curved spacetime, while particles remain separate fields. Here, by contrast, contortion itself is the source of mass-like or energy-like effects. When torsion is particularly strong in a region, that area can appear dark, meaning it does not couple effectively to light. We might interpret such twisted zones as an analogy for dark matter, since they create gravitational effects, pulling other lumps and filaments together, yet remain mostly invisible electromagnetically. Think of it as a rugged or rippled spacetime. Lumps of high contortion do not allow light to pass in a simple, linear fashion, so these zones stay less transparent, behaving similarly to how one would expect dark matter to act on cosmic scales. The gradient of torsion, which we can call nabla K, shows how contortion changes from one region to another, influencing whether filaments appear or disappear as the nodes move. All of this can be summarized by a single overarching principle. Rather than a smooth geometry governed exclusively by Einstein's curvature, we have an enriched spacetime geometry where torsion, or contortion, yields extra twisting behavior. Regions of high torsion density naturally clump up, forming nuggets that bend or swirl the fabric enough to be recognized as massive lumps, yet stay dark if they barely interact with electromagnetic waves. In effect, matter and geometry become two sides of the same torsion curvature continuum. By watching how the filaments strengthen when lumps approach, and weaken when they drift apart, you get a sense of how contortion organizes these structures. In a full general singularity framework, such clusters and filaments can span cosmic distances, suggesting a network reminiscent of the large-scale cosmic web, except here it emerges from both curvature and torsion. This can explain certain gravitational effects that luminous matter alone does not account for, pointing to a natural geometric origin for dark matter-like phenomena. Surprisingly, the idea of twisting structures carrying crucial information also shows up in topological quantum computing, like the so-called Majorana 1 chip. In that approach, special quasi-particles called Majorana fermions become pinned to vortex cores in a topological superconductor, forming robust quantum states. Those states remain stable despite various disruptions, much as our contortion lumps persist due to integral constraints. Thus, whether we speak of quantum computing or cosmic torsion, both rely on topological stability and twisting effects, underscoring how geometry and topology can unify widely different physical realms. In the equation, hat r plus k² minus nabla k, subscript ab, equals 0. End quote. In simpler terms, it says the usual Einstein-style curvature, referred to as hat r, must balance with the twisting density called k² and its gradient, called nabla k, so that together they produce what looks like matter and gravitational effects. Where k² becomes large, the geometry twists into lumps that can mimic mass or dark matter, even if they do not shine like ordinary objects. If nabla k, meaning the rate of change of that twisting, grows too steep, it redistributes or cancels some lumps. Meanwhile, hat r is just the standard bending of spacetime. By forcing all three, hat r, k², and nabla k, to zero out in one unified statement, the equation shows how stuff like mass or dark light clumps can arise purely from geometry, without needing separate matter fields. Essentially, geometry is no longer just curved, it is also twisted, allowing those twists to form and dissolve lumps that we interpret as mass, energy, or dark matter.